everyone, welcome to Chuhan Physics Tutorials. So today I'm going to discuss about the difference between distance and displacement. So let's start with the definition. The distance is the actual length of path traveled by an object, and the displacement is the shortest length between initial and final position of an object. So let's start with the help of an example. Let us consider a point A. Object started from here, reaches the point B, then after that reaches the point C. Okay, so object started from A, then B, after that C. So this is the actual path traveled by an object. It is known as distance. But if you look at here, this is the point from where the object starts its journey, and this is the point C where it ends its journey. So the starting point, it is known as the initial point, and the ending point, it is known as the final position or final point. So object wants to start from A and ends at C. So we can the object can also choose this path A to C. So as we can see, this AC path, it is the shortest distance between A to C. So this distance, it is known as displacement, and this whole path, it is known as distance. So I hope the difference between distance and displacement is clear. Now let us take one more example. An object started from point A, then this is the final point B. Object wants to reach here. There are two ways. One is the object can choose the actual path to reach from A to B, and the second path is, that is the straight path. The object can start from A and straight go to point B. So as we can see here, this path, it is the longest path of the actual path. So this path is known as the distance traveled by an object, and this is the shortest path. This is known as the displacement done by the object. And one more example I'm going to show here. The object started from point A, wants to reach point B. In this case, let us suppose the object started from the point A, reaches point B through this curve, and there is one more path, that is object can start from this point A and reaches the point B. So this is the actual path known as distance, and this path is the shortest path known as displacement. In this case, the distance is equals to 2 pi r divided by 2. Why it is this? Because it is a semicircle, and in this case, the distance is equal to half of the circumference. And this displacement in this case is, it is 2r, which is equals to a diameter of circle, semicircle. So I hope the distance and displacement is clear. Now come to the next point. The distance, it is a scalar quantity, and the displacement, it is a vector quantity. Scalar quantity means the quantities which having only magnitude. Magnitude means value. And the vector quantities which having magnitude as well as direction. So in displacement, direction also matters. Here, if we take this case, the object started from A to B, B to C. So we are only looking for the value, how much total distance has covered. But in case of displacement, we are looking from where the object started and where it ends. So direction matters in case of displacement. So displacement is a vector quantity and distance is a scalar quantity. Now come to this third point. It remains positive, can't be zero, negative. If we look at here, this distance is 3 kilometer. This distance is 4 kilometer. By applying Pythagoras theorem, we can find this distance also. Let us suppose by Pythagoras theorem, it is 5 kilometers. So it is clearly that distance is 7 kilometer and the displacement is only 5 kilometer. Here also, if we calculate the value of pi r is greater than the value of 2r. It means distance is greater than displacement, and distance is always positive. Here also distance is positive. So distance is always positive, but displacement can be positive, negative, or zero. Let us take a case where the displacement is zero. So object started from a point P, okay, and after completing a journey, it comes back to the point P. Okay, in this case, the distance is given by formula 2 pi r, because this is a circular path. In circular path, distance equals to the circumference of the circle. So it is 2 pi r. And in this case, the displacement is equals to 0. Why it is 0? Because when the initial point, we can say initial position and final position is same, in that cases the displacement is 0. It is also possible in a straight line. The object started from point A, reaches the B, then C, after that B, and then comes back to the point A. In this case, the distance is AB plus BC plus CD, then after that DA. But the displacement is 0. Why it is 0? The object started from A and reached back to the A. That means initial position and the final position is same. And the displacement, it is calculated by the formula, the final distance minus initial distance. So you can also apply the formula here. Final is this dA, and the initial is AD. AD, dA minus AD, same value, it becomes 0. I hope this point is also clear. Now come to the fourth point. The fourth point is, wait, the fourth point is the distance is always greater than or equals to the displacement. So I will explain it now. As you can see in the various examples, that in this case, the distance is 7 kilometer, the displacement is 5 kilometer. The distance is greater than displacement. Also in the second case, here, we look at here, pi r, it's greater than 2r, distance is greater than displacement. Here also, distance is greater than displacement. So distance is always greater than displacement. One more case is here, that distance is equals to displacement. In some cases, distance is equals to displacement, and it is only possible in the case of linear motion. An object is traveling in a straight line, at that time distance equals to displacement. So we can also write distance is greater than or equals to displacement, but distance can't be less than displacement. That's why displacement distance is never negative. Okay. Now, one more point we can add here, that is, I already told you that in the displacement, we are looking for the initial position and final position. But in the case of distance, we are only looking for the path and which path is followed. So, distance, it depends upon path. So, distance, it depends upon path, but displacement, it is path independent. Or we can also write the displacement is position dependent, because it depends upon the initial and final position. I hope the difference between distance and displacement is clear and you find this video useful. Thank you. Like, share and subscribe to Han Physics Tutorials.